This video will just give you an idea of what it's like to kind of graph a basic polynomial and factor and use end behavior to help you out with your sign, your leading coefficient sign. So the first thing I want to talk about is if it's already factored for you, in order to get, like if I'm asking you what the degree of this polynomial is, you would have to actually add the powers, the exponents together. Because if you distributed all the way through, you would want your highest power of x, and that would be 4, 5, 6, 7, 8, 9. Okay, just to give you an idea. The leading coefficient is this number that's like your a value on a quadratic. That's called the leading coefficient. That is going to help you determine your end behavior. And then the other thing is with your powers, if it's a fourth power, which you won't have a lot of, but if it's a fourth power, on the graph, that is this very, very flat piece where it comes up and touches the x-axis and then it goes right back down. So this is a fourth power. A squared does the same thing, but it's more, kind of more curve, has more curve on it. So this would be like a second power squared. And then a cube, this is like a cube power. It will like flatten out and then touch the x-axis and then go back up again. So this is a third power. It flattens and then keeps going in the same direction. So if it started going up, it just keeps going up and flattens out on the x-axis. So then what you can tell, the behavior on the ends of it is going to help you kind of get a sketch of your graph also. So this one, just think of it, it goes up to the right. And it goes down to the left. Okay, so what that tells you, if one of them goes down and one of them goes up, that means your degree is odd. So if you look at this picture right here, if your degree is odd, so remember the degree is the highest power. If that's odd, one end will go down and one end will go up. Okay, so then you've got to look here. If the leading coefficient is positive, then it's down on the left and up on the right. If the leading coefficient is negative, then it's up on the left, down on the right. Okay, if it's an even degree, then either they both go up. If it's positive for the leading coefficient, they both ends go down if it's negative for the leading coefficient. All right, so just to give you an idea of what's going on here, we're going to write some equations for polynomials. So like number one, what you would want to do is just kind of look at your end behavior. So this tells me they both go up. It's an even. The degree is even. And since they both go up, the leading coefficient is positive. I'm going to abbreviate that LC. That is positive. And then you're just going to use like the idea of the roots that I talked about. The second power, a fourth power, a third power, and a first power. And I'll kind of show you what a first power is to help you write your equation. So you have a root here, you have a root there, and you have one here. Okay? So if it just goes straight through the axis, that is called a single root or a first power. Okay? So then it comes back down and then it touches, and right after it touches, it goes back the other direction. That is a double root. So that will be a second power. And then we come back and then it goes straight through. So that's another single root. So when you write your function, just put your f of x out front, function notation. And then your leading coefficient is positive, so we're just going to leave it positive out front. This root is -4/3, so that is like x equals -4/3. So if you think about it, if you worked backwards to get the factor, you could just multiply by 3. 3x equals -4, and then add the 4 over. So your factor would have been 3x plus 4, if that makes sense. And since that's a single root, your exponent, you don't need to write one there, but that would just be like to the first power. And then you have a double root at 0, at x equals 0. So remember, that would just be like x. And since it's a double, you're going to put a 2 or a squared for your power. And then we have another single root at 3. So again, go backwards. Your factor would be x minus 3. And then that was a single, so that would be a first power again. Just to simplify it a little bit, most of the time you'll see the x squared out front. And then just 3x plus 4, x minus 3, like that. That would be your final equation. Number 2, you have this would be a double, because it hits it and then it goes right back the other direction. This one goes straight through, so that's a single. This one, do you see how it goes through it but it flattens out? That's a triple. That's a triple. At x equals 2, a single at x equals 0, a double at x equals -1. Okay, and then the end behavior, it goes up on both ends. So your leading coefficient should be positive. So then it's pretty easy to get your general function. You want positive out front. You have a double root at x equals -1. So add that 1 back over. It's a double, so square it. You have a single at 0. So x to the first, you don't need to put a 1 there. And then you have a triple at x equals 2. So that would be like x minus 2. And then since that's a triple, you cube it. So the better way to write it would be, put your x out front, x plus 1 squared, x minus 2 quantity cubed. Okay, number 3, you have a single. This one goes straight through. Single at 0. This one goes straight through. 1, 2, 3. A single at 3. And that one goes straight through, so you have another single at 6. Unfortunately, I put 3 kind of the same end behaviors. Those both go up again, so your leading coefficient will be positive. So f of x equals a single at 0, so x to the first, a single at 3, so x minus 3 to the first, and a single at 6, subtract that 6 back over, x minus 6. Okay, that kind of hopefully gives you a little bit of an idea of what's going on. Oh, I forgot one of them. I don't know if you noticed that. There's also a single at 1. The reason I knew I forgot one is because if both ends go up or down, then the degree should be even. and this was still odd, 1, 2, 3. So I need to do x minus 1 here. There. And that was a single. Okay. Some other things that you're going to do is you're going to write a function using some given information. So like if I tell you there's a double root at 4, convert that, that would be like x minus 4 squared, since it was a double. A single root at negative 1, add that back over, that would be like x plus 1, a single to the first. A triple root at 2, so x minus 2 triple would be cubed. And then a double root at 0, that would be like x squared. And then it says assume the leading coefficient is positive. So we'll just leave it positive out front. I'm going to start with the x squared. And then I'm just going to list the other ones behind it. X minus 4, quantity squared, x plus 1. That was to the first, so I'm just going to leave it without an exponent. And then x minus 2, quantity cubed. And then the last part I have is just kind of showing you how to sketch the graph. So if it's already factored for you, it's quicker. So I did one of each. This one, the leading coefficient is negative. And then the degree, since it's factored, I'm going to have to add these powers together, 3, 5, 6. The degree is 6, and that's even, right? So if you look at that chart on the front, if the degree is even, and the leading coefficient is negative, then that means that both ends will go down to the left, down to the right. Okay, so we're going to go down, left, and down on the right. And then our roots would be at x equals 0. This one would be x equals 0. This one would be x, think of it like x minus 1 equals 0. So x equals 1. And that one would be x plus 4 equals 0, so negative 4. I would start by just putting a point at those x-intercepts, so 0, 1, 1, 2, 3, negative 4. And then you're going to see if it's a single root or a double root. So at this negative 4 one, that's a triple. So remember, at a triple, it flattens out, but keeps going in the same direction. So if my end is supposed to go down, I'm going to flatten it out here, like this, and go through there, like that. And then 0, this is a single. So remember, a single just goes straight through. It doesn't approach it, it doesn't curve there, it approaches it and goes straight through it. And then I have at 1, I have a double. So remember what happens at a double. It's going to hit it and go right back down. And this makes sense because your end behavior, it's supposed to go down on the left and down on the right. Okay, so I started down here. Negative 4 was a triple. So I flattened it, went through. And then I don't know where this height is. You would have to make a table to figure that out. We're just going to sketch it. So then come back down. At 0, you have a single, so just go straight through. Pick a spot, turn around, and then 1 was a double. So hit it, come right back down. Okay? The second one I did, it was not factored. So what you're going to do first is factor it if you can. So look for a greatest common factor. This one has an x cubed for all of the terms that it has that in common. So then I would have 2x cubed plus 5x squared minus 2x plus 5. And then remember, you're going to group. Since you have 4 terms left, you're going to try to group it. So that would be x squared 2x plus 5 minus 1, 2x. So that's not going to factor because that would be minus 5. I'm going to go back to the original. I'm going to change that to subtraction so that it will work for us. So this would be minus, and that'll be plus. So then when you factor all the way, it'd be f of x equals, don't lose your x cubed, and then you have 2x plus 5, and you have x squared minus 1. Okay? And actually, this x squared minus 1 will factor again. It'll be x minus 1, x plus 1. So what happens is you have a triple root at 0, triple at 0, a single at, solve that, negative 5/2. That's a single. And then a single at 1. And a single at negative 1. So let's see, I'm going to mark 0. Negative 5/2 is negative 2.5. 1 and negative 1. Okay, and then my degree was even. Since it was not factored, I just take the highest power. That's my degree. If it's factored, you just add the power. So 3, 4, 5, 6. You still get 6 either way. And that's even. And then the leading coefficient is positive 2. So remember, if it's even and positive, it'll go up to the left, up to the right. Okay, so I want it to go up on the left, and negative 5/2 is a single, so I'm going to go straight through here. And then negative 1 was a single, so go back up, straight through it. 0 is a triple, so you're going to come down, curve, go through, you're going to flatten out there. It's going to be kind of tricky to do that, but make it look like it flattens out. And then 1 is a single, so just go straight through it. So right here, just try to flatten as much as you can. So hopefully that gives you an idea of what you should do when you are graphing polynomial functions.